Hello everyone, welcome to today's video. Today is a very important video because COVID-19 has been spreading like anything, and as I have discussed in my last video that we as engineers can try to bring out solutions to the problems, to the real life problems. And what is a greater challenge than to serve the COVID patients in these times of need, and how can we do that as engineers? We have the prime advantage of knowing the processes in the industry in particular, and we need to find an economical and an easier method to produce oxygen. Citing the oxygen crisis in India right now, particularly in states where oxygen production units are not there. In Delhi, particularly, there are about 2 crore people who are not getting proper oxygen because Delhi has to import oxygen from the other states, and hoarding of oxygen is taking place in the other states because no state is wanting to give oxygen. And in these times of need, we really need to step up and do something for our state, for our country. And today I am going to discuss that method of oxygen production, which is very economical, which is very cheap. And if you are watching this video, even if one person is watching this video, please follow this method. It would just take you about a few minutes to understand the method, and then undergo some study on it. Try to design a process like this if you are a chemical engineer or any other typical engineer, because this is very economical and it can be implemented in the hospitals. I am myself implementing it in a government hospital in collaboration with the government right now, and we are in a trial phase. We have made a prototype of this, and we are in a pilot plant trial phase, collaborating with the hospital in itself, and we are trying our level best, and we want you to do the same. So today, straight away, going to the topic of oxygen production, the cheapest and the economical most and the easiest most method, that the PSA method. Now oxygen, primarily when we talk about gas separation, there are several methods of producing oxygen. Oxygen concentrators are basically working on the principle of electrolysis of water. We know water is primarily constituted of hydrogen and oxygen atoms, and when we electrolyze water, we can actually generate oxygen gas from one of the electrodes, and that serves as the principle of the oxygen concentrators that are used generally for the COVID-19 bed patients. You can undergo that method. You will find several videos on the net regarding this electrolysis of water. But what about oxygen production in bulk, when you need to open a pilot plant producing about 10 to 20 metric ton? The plant that we are working on, it's producing 50 metric ton per day for the hospitals that we are launching. And if you can get some government funding from the PM Cares Fund, as the PM Cares Fund has recently declared that it's going to open 551 plants all over India, this method is very, very helpful. And even for general knowledge, you should know this method of oxygen production, the cheapest and the easiest method of oxygen production. When we talk of gas separation, electrolysis is definitely extracting oxygen from liquid. That's a separate method. Oxygen concentration, oxygen concentrator principle. Here we are talking of gas separation, that is from air, that is so much abundant all over. Wherever we are surrounded by air, and air is primarily constituted of 79% nitrogen, 79% N2, and 20.5% oxygen approximately, and the rest of it is argon and other inert gases in the atmospheric air. Also some CO2, traces of CO2 is present, but primarily it is constituted of oxygen and nitrogen. And our primary task is to separate the nitrogen from the oxygen, and extract the pure oxygen that's present in the air. Because it's so much abundant, we can easily take air and take out the oxygen from the air. And what better than this particular PSA method, pressure swing adsorption method, to produce oxygen, that is to extract oxygen from the air in itself and removing the nitrogen. So this is a gas separation method. When we talk of gas separation, the first thing that comes to our mind is adsorption, and absolutely so we are following this principle of pressure swing adsorption. Here we are going to talk about what is the procedure. And another method of oxygen production that is typically followed in most of the industries and plants is cryogenic distillation. Apart from this PSA method, another famous method, as I told you, is cryogenic distillation. Now, as the name suggests, it is a distillation procedure which is undergone under cryogenic conditions. Cryogenic is minus 190, minus 180 degrees Celsius. That is the boiling point of oxygen. Boiling point of nitrogen is minus 195.6, and boiling point of oxygen is about minus 183.5, if I'm not wrong. So taking them to that lower temperature under high pressure and undergoing distillation such that the nitrogen having a lower boiling point than oxygen will tend to remain primarily as liquid, and the oxygen having a tendency of easily forming vapor, easier than nitrogen, it has a tendency to primarily remain as vapor in a distillation column, and using that principle, cryogenic distillation is followed to separate oxygen and nitrogen from the air in itself, which is acting as a feed. But here we are using a adsorption method and not a distillation method. So first of all, oxygen production can be undergone, oxygen concentration can be undergone by electrolysis of water. Oxygen production can be undergone by two methods in primary which are followed in the industry. One is the PSA method, that is adsorption. That is the easiest and the economical most method that you can implement even by yourself by designing a small pilot plant and taking this effort ahead. And the other one is cryogenic distillation, which we are not going to discuss, but just giving an overview of how it is done. It is first converted into liquid, both nitrogen and oxygen, and nitrogen prevalently remains as liquid in the bottoms of the distillation column, and under those conditions oxygen tend to form vapor and get separated from nitrogen and is collected at the top. But talking of the PSA procedure, just to give you this idea that this is my compressor, which is basically drawing in the air from the atmosphere. The atmospheric air is being drawn in by the compressor and compressed under high pressure, and then it is passed through a filter and a dryer, which is very important because the air primarily contains dust particles, primarily contains a lot of suspended solids, so that needs to be separated, and it contains water as well, which might create a lot of problems in the packing columns when we entrain the air along with water. So we need a dehumidifier, or we need a dryer in specific to draw out that water vapor from the air in itself, and a filter that filters out the dust particles from the air. So the dust plus water is removed in this particular section, and pure air, as we can see, moves ahead of the filter and dryer. This filter and dryer will be easily available in the market. You can approach a few companies like Suez India in particular for this membrane separator or this dryer or filter in particular, which can act as a typical filter to separate out the dust from the air. They serve in filters, so you can approach Suez India, or other companies are there which serve as strong filter sources. It depends on the amount of air you are treating, how big you need a filter, how big a filter do you need, or how what is the pore size of the filter. Depends on the dust particles you are handling. If you are handling too dusty air, then you will need a smaller pore size filter. Otherwise, you can have a series of cyclone separators or series of filters as well, so that you can further purify the air. But in general, the air around us is not that kind of dusty, so we can use a regular filter that is manufactured by a good company like Suez India or something like that, and we can get a dryer along with it, a dehumidifier, which is also available in the industry. So if you get the funding, you can actually produce pure air, and then you store the air in a storage vessel. You create a pressure, under high pressure you store this air, and then you finally send it to a adsorption tower. Yes, adsorption and not absorption tower. Adsorption is basically a surface phenomena. The gas tends to get adsorbed on the solid surfaces. Now let me tell you what happens is, you are seeing that there are so many valves. Let me first make it clear. As the name suggests, pressure swing adsorbers. Here comes the main principle. Pressure swing adsorption is basically a method where you first increase the pressure, undergo adsorption, then throttle or decrease the pressure to undergo desorption. So first adsorption is taking place, then desorption is taking place. First adsorption is taking place, then desorption is taking place. Adsorption of what? Adsorption of nitrogen. Once the nitrogen is adsorbed, what is left in the air? Only pure oxygen, because you have already separated out the dust and the water, and pure nitrogen is separated out, is adsorbed on the solid surfaces. So only left is oxygen, which is going into this oxygen chamber and finally to dispatch or to the bottling plant. So you need to understand this concept. What are these valves? First, let us understand the cycle of adsorption. The cycle of adsorption. This valve is open. In the cycle of adsorption, this valve is open. Supposedly this valve is open and this valve is closed. So air goes from air, enters through this and goes into this adsorption tower. Now as it goes into this adsorption tower, the pressure is increased immensely. So the pressure in the adsorption cycle of this particular tower where the gas is entering is sent high. As the pressure is high, under high pressure, the packings in this particular chambers absorb the nitrogen from the air. Now what are these packings? What are these packings? The packings you will have to understand are zeolites, zeolite packings, activated carbon or charcoal, asbestos, nickel, all of these are very strong absorbing agents. Sometimes you use adsorption columns in series so that further nitrogen can be separated and pure oxygen can be obtained. So you can use adsorption columns in series with different kind of packings, but the packings primarily are zeolites, activated carbon, asbestos or nickel. So these type of compounds under high pressure absorb N2, absorb N2 when the pressure is high. So basically this is the structure, supposedly. Then N2 is attacking the surface pores, the surface areas, and getting absorbed. So N2, once it is got absorbed, you open this valve. So this valve is open, this valve is open, this valve is open, this valve is open. So we see the oxygen, the pure oxygen passes from this valve and gets stored in the O2. This valve is closed. This valve is closed. So you see that no air is getting passed into this adsorption column that is in parallel to this. Now comes the desorption cycle, my friends. Very important, let me tell you. What happens in adsorption? The gas is passing through this adsorption tower, getting absorbed on the surfaces of the zeolites or activated charcoal or whatever it is, the packings, it's getting absorbed. The nitrogen in particular, the oxygen pure, is escaping out and is getting stored in the oxygen vessel. Now in the desorption section, when the saturation pressure is reached, that is the entire, all the surface areas, all the activated centers of adsorption are taken up by the nitrogen. No further adsorption is taking place and the purity is getting hampered. You are getting some amount of nitrogen along with it. So you need an oxygen analyzer here, O2 analyzer, O2 percentage analyzer. So as we see, as the percentage of O2 decreases, the percentage of N2 increases in the outlet, we understand that all the pores are being taken up by the nitrogen and no further separation of nitrogen can be undergone in this particular adsorption tower. We need to regenerate this adsorption bed so that the pores open up again, free for further nitrogen adsorption. How do we regenerate the bed? This is the cycle of desorption. Now what happens is, when we get the pressure high, now what we do is we close this valve. This valve is still open, this valve is still open, we open this valve. In the desorption cycle of this particular column, we open this valve and start the adsorption cycle in this particular column. So when the parallel column is undergoing desorption, the other parallel column is undergoing adsorption simultaneously. This valve is open and this valve is open. So same phenomenon is taking place. Here the pressure is kept high in the desorption cycle. In the desorption cycle of this column, this pressure is kept high so that adsorption takes place in this particular column, column 1, let us say. This is column 2. When column 2 is undergoing desorption, my friends, column 1 is undergoing adsorption. Now, how does the desorption take place? The pressure is dropped. It's throttled. The high pressure maintained here is no longer maintained high as we block this valve and this valve. No high pressure is maintained in the chamber and throttling, flashing occurs. The pressure is released. The pressure is dropped in the desorption cycle. And as the pressure is dropped, I told you, under low pressure, my friends, this N2 tends to go back. N2 tends to get released under pressure, low pressure. Whenever the pressure is low, the desorption cycle takes place, or the adsorbed material try to escape out from the activated pores. From the pore structure, it gets dissolved because the pressure is maintained till then, and you release the pressure, the nitrogen tries to escape. Now where will it escape from? Where will it escape from, my friends? I have blocked this, it will escape from here, so I let this open. So nitrogen is purged out from here. And when this section is undergoing desorption, my friends, again we open this and we undergo adsorption in the regenerated zeolite bed or asbestos bed that we have regenerated by desorption of nitrogen. We have let the nitrogen out by dropping the pressure, and then we again increase the pressure to further undergo adsorption of the remaining nitrogen. In that process, this valve and this valve is again closed and this valve is opened so that the nitrogen can escape from here. This bed nitrogen. So again, the bed of adsorbent is regenerated. This is the pressure swing adsorption. First you undergo high pressure to absorb the nitrogen and let out the pure oxygen. Then you throttle the pressure, decrease the pressure so that the nitrogen that was adsorbed in the adsorption phase or adsorption cycle is dissolved back, and nitrogen is purged out of the system so that the bed gets regenerated. and once the bed gets regenerated, again the cycle is continued, and we keep two in parallel such that the supply can be continuous. While desorption is taking place in one bed, absorption is taking place in the second bed. The adsorbers can be another in series, or 2 or 3 adsorbers can be used in parallel. In our case, we have used only 2 adsorbers, and this conditions can be easily maintained. You can use ceramic balls for packing, and in between you can keep the zeolite bed such that the gas evenly gets distributed and the nitrogen is trapped on the zeolite structure. So you see, this packing bed is not difficult to manufacture. This compressor is even easily available in the market. This filter press dryer is easily available in the market. This storage vessels can be made available in the market. And finally, the dispatch is directly connected to the hospital oxygen line, or it is sent to a bottling plant wherein bottling of oxygen in oxygen cylinders do take place. So if you are seeing this video till the very end, then even if one person is seeing, please do try this procedure. Please do try to make this kind of a oxygen analyzer, oxygen generator, because the patients are really in need, not only in India but outside India as well. If you are an engineer, please try to help in your way. That's it for today. There are several other methods to produce oxygen, but this is the cheapest, most economical and the easiest method. You can also follow the method that is being suggested by 2 IISER professors. IISER Bhopal, 2 professors have developed a certain method wherein oxygen can be manufactured by H2O2, hydrogen peroxide, by undergoing certain chemical reactions. You can refer to that as well. The articles of which are available on the net, you can search on that, and you can contact the IISER professors directly so that you can undergo that process. That will be it. Try to help your best, try to come out of your shell, and try to reach out to the people, try to help. And if you liked our video, like it, share it with your friends, subscribe to our channel, click the bell icon for regular updates, and that's it for today. Thank you very much.